GC3 Green Chemistry Innovation Webinar Series, where we're examining various innovation models and programs that either are currently being used or can be used to advance green chemistry research, development, and adoption. And as some of you may know, if you were able to join us a few weeks ago, our first webinar, we heard from Professor Kai-Cheng Lee of Oregon State University, and Dr. Lee has quite an impressive track record of commercializing highly lucrative green chemistry technologies. And he talked to us about the challenges of getting funding for R&D, dealing with IP issues in an academic setting, and how he has developed a portfolio of strategies to work with companies to bring his ideas to market. It was really a fascinating presentation, and Dr. Lee was quite candid about the challenges and the lessons learned, and I think it really ties in nicely to what we'll be hearing today. And if you missed that webinar, just be aware that we do have an audio archive that you can pull up from the GC3 website. And I mentioned just a few minutes ago, on October 23rd, we'll have Alf Bingham from Innocentive, who'll talk about crowdsourcing innovation and challenge-driven innovation, and that should be really fascinating as well. So please register for that if you haven't already. But today, we are very pleased to have Dr. Rui Resendes from GreenCentre Canada to talk about their unique and successful business model for pulling green chemistry ideas out of the lab and into commercial application. And before I turn it over to Rui, Rui, if you could advance to the next slide, I'll just quickly go over how we're going to do the call today. Let's see. Well, Rui, can you advance one slide?
Oh, I did.
Yeah, okay, okay. There might be a delayed reaction. Let's see. I'm not seeing the second slide. All right, well, that's not good.
It's staring right at me.
Okay, okay, yeah. We're getting a glimpse of it now. Boy, it's really delayed. Or maybe it's delayed on my computer. So why don't I just go ahead. What we will be doing is we will be asking Rui to go through his presentation. We have all lines muted. And if you have a question during Rui's presentation, just type it into the Q&A box, which you can access from the control panel at the top of your screen. There's a down arrow. You click on that. You click on the Q&A box. You can type in a question. And I'll be collecting questions during Rui's presentation if you'd like to put a question up, but I'll be holding those until the end. And after his presentation, I will pose the question to Rui. We'll keep everyone on mute. And you can also, of course, type in questions at the end of the presentation as well. So let me quickly do an introduction to Rui and then turn it over to him so he can get us going. So Dr. Rui Resendes graduated from the University of Toronto with a PhD in chemistry and a specialization in advanced materials. Since then, he has filled numerous leadership roles in research and business development with Bayer Material Science and Lanxess. In 2007, Dr. Resendes assumed the role of Director of Commercial Development, Chemistry and Materials at Queen's University's Partech Innovations, which is one of Canada's foremost technology transfer offices. Shortly after joining Partech, Dr. Resendes led the creation of GreenCentre Canada, an exciting new commercialization model that is the first of its kind in North America. In 2009, he was appointed the Centre's Executive Director. And we are thrilled, Rui, to have you here with us today. And please take it away.
Great. Thanks so much for the opportunity to speak to everyone out there in webinar land. And I guess I'd like to preface the presentation by mentioning that I'm a Portuguese fellow, and like every good Mediterranean boy, I talk passionately and wave my hands. And you're not going to be able to see that. But just picture that. You know, there's going to be a lot of hand waving as I go through this presentation, because it's something that we're really excited about what we've been able to do over the last 5 years. Taking this paper-based exercise, which we had a horrible name at the beginning, something like the Center for Green Chemistry Commercialization in Canada. I think that's what we call that. And then we've truncated that to something much more catchy, GreenCentre Canada. But the mission has remained unchanged since day one, and that is to to really realize the potential of green chemistry innovations through commercialization, so through getting them out of the lab and into the marketplace. And I thought I'd start the presentation with what we view as a snapshot of the world. And if technology is cooperating with us, you should be seeing a kind of a three-part picture where you're getting a glimpse into everyday life in North America. And the reason I put it up there is because this is a snapshot of our world. But if you were to take chemistry out of it, that's what it looks like. I mean, there's essentially nothing there. So that's quite a statement to make. And for all the chemists that are participating, I'm sure everyone's nodding their heads. Yep, the world's pretty much vacant without chemistry. But for the non-chemists, let me just expand on this a little bit more. Chemistry is at the heart of everything we do, right? I don't think you can think of anything that isn't enabled by this principal manufacturing sector. I mean, it's a huge manufacturing sector. It's responsible for about $3.8 trillion in business a year. If you look at just the turnover associated with manufacturing and shipments of chemicals and chemical services, it actually starts to approach $5 trillion a year. And just about every job on this planet is enabled by this sector. All of our prescriptions, our forms of transportation, our food, our clothes, our gadgets, anything you can think of is made possible by this industry. And we've come to draw on it over the last 200 years, and we've come to develop a standard of living which is intimately linked with the products and services that this industry provides. However, it also introduces a dilemma. The dilemma is that while we draw on this industry for our way of life, there are some not so nice collateral effects of this industry. Things like damage to the environment, things like depletion of non-renewable resources, for example, fossil fuel resources, and of course the generation of products that represent challenges to human health. All of these things are the not so nice side of the chemical industry. So the challenge before us as a society is how do we address this dilemma? Right? How do we continue to draw on the products and the services that make our quality of life possible, but in a way that does not do damage to the environment, that does not present human health challenges, and as importantly, continues to drive this economic engine? And the answer I'm sure you all know the punchline because that's why you're all on this call, it's green chemistry, right? It's just a very common sense approach to manufacturing, to service provision that looks at things holistically. It looks at manufacturing chains holistically and designs and deploys technologies that can continue to meet society's needs, society's demands, but in a way that does not introduce damage to the environment, does not draw on non-renewable resources, and does not liberate any byproducts into the environment which represent human health concerns. That's the spirit of green chemistry. And it's not a choice. I mean, this is one of these challenges that we face today as a society that history will judge us on how we address, because there is more and more of us every day. I mean, we're well over 7 billion people on this planet, and these 7 billion people either have or aspire to have the quality of life that we in Canada and the U.S. take for granted. And to put that in perspective, I mean, if you were to snap your fingers and give everyone on this planet the same quality of life that we enjoy in Canada and the U.S., you would need 4 Earth equivalents of resources in order to satisfy that demand. It's a fundamental disconnect, which is not meant to invoke panic, but one that's meant to draw attention to the challenge we have in this sector, and the need to draw on the chemical industry and view it as a source of innovation, and not simply vilify it for all of its negative side effects, but embrace innovation within it so that we can reinvent manufacturing value chains to bring to market products and services that address needs and demands without introducing any of these negative side effects. That's the real spirit of green chemistry, and that is the focus of our organization. And we look at this challenge and we look at it from a commercial lens. So we acknowledge that there is a tremendous wealth of innovation that exists, that is being continually generated from the academic research communities, from the entrepreneurial communities around the world. And these early stage eurekas, if you will, have the potential to transform manufacturing, to transform consumer products, to transform consumer and industrial services in a way that is sustainable and in a way that can be enjoyed not by not just by our generation, but our grandkids and their grandkids. That's what we focus on. I thought I'd start by putting up a picture of the team because I think it's important to emphasize the way in which we approach our business, and that is through a very hands-on approach to commercialization and a very holistic approach to commercialization, where we have commercial people working alongside technical people working alongside business professionals, all of whom are directing their specific competencies at early stage technologies, getting them developed, de-risked, properly positioned, and properly quantified so that we can attract the kinds of development and investment dollars needed to ultimately launch them into the marketplace. And it's these commercial transactions that are key for us as an organization because they not only ensure that a technology will manifest itself in the marketplace and we can draw on the benefits from it, but it'll keep us focused on and help us define the commercialization strategies and guide our triaging activities with respect to what technologies we actively invest in and which ones we actively launch forward. So it's with this team that we execute our mission. And our mission, as you can see in our tagline, it's quite a big one. I mean, to change chemistry and to change the world. And I think if you reflect on what I said at the beginning, I mean, this indeed, it is possible to hone the chemical sciences in a way that can change the world. Reinventing manufacturing, reinventing consumer products and industrial services can have a positive effect on this planet. And the goal for our organization is to identify these game-changing technologies and recognizing that most of them, if not all of them, are in a very, very early stage of development. And how do we get them to the marketplace so that we can realize their benefits? And ultimately, this advances the human condition. And I mean, this term "human condition" is thrown around a lot. It's typically congruent with many philanthropic organizations' charters. But in the case of our organization, in the case of the chemical sector, we believe that we can advance this human condition by introducing products and services that do not represent challenges to human health, that represent environmentally sustainable technologies and sustainable solutions to address consumer needs, and at the same time provide economic prosperity. Largest manufacturing sector in the world, the way to drive an economy is to have a healthy chemical and materials manufacturing sector. At the heart of our organization is a 10,000 square foot facility where our team is able to take this important hands-on approach to commercialization. And if looking at this picture, and for those of you that have had the opportunity to tour our facilities, at the end of the day, it is a very nicely equipped synthetic chemistry lab. And it is not dissimilar from the type of equipment and type of infrastructure you would see at an academic research lab. The equipment is the same. The activities have a business focus. So while the academic community is charged with continually advancing the science and breaking the boundaries of our current understanding of science, these same people and the same infrastructure is not deployed at building a business out of innovation. Yet the initial activities that are needed to support the development of a platform into the form of an early business are the same technical activities, but they have a very different focus. So they're not to advance the science, not to redefine our understanding of basic molecular synthesis, but to develop commercial prototypes, to test those prototypes in consumer applications, to develop manufacturing processes for those chemicals or materials, to determine costs of production, and to determine fit within existing and evolving regulatory frameworks. These are the kinds of activities that our technical team undertakes, but in collaboration with our commercial and business team, because it takes more than just a clever technology to advance a platform to the marketplace. As those who participated in the first webinar series heard about the challenges associated with not having or having a poorly defined intellectual property position around their technology. And that's something which we focus on right from day one. And it's this activity with the technology activities, with all of these other activities shown up on the slide, that give us this, this holistic approach to nurturing these early stage technologies into a platform which can attract additional development investment or or venture capital if the technology is ultimately going to manifest itself in the form of a new company, a new technology company. So you can see these activities. They're quite broad. They're not just technical. They're not just business. They're not just development, but they're all of the above. And that is the critical part of I guess our approach to getting technologies developed. So it all starts with disclosure. And that's, to get into the nitty-gritty of how we do business, I think let's start at the beginning. And the beginning is to identify those early-stage technologies. And for the most part, although this is rapidly changing, when we started 5 years ago, we drew almost exclusively on academic research in Canada as a source of those innovations. However, as we move forward, and where we are today, we see that we have pretty much a 50-50 split between academic and entrepreneurial technology sourcing. So we're seeing that not just across Canada, but across the U.S. and in other parts of the world where we've been able to do some business, that the opportunities in early stage technology exist both in the academic research space as well as the entrepreneurial sectors. So our first step, the disclosure. We need to find out about the technology. And if the technology is coming from an academic institution, one of the first steps for us is to work with the institution's technology transfer office or the industry liaison office to not only formally receive that disclosure, but to execute all of the necessary agreements so that we can not only ensure that confidentiality is kept, important for intellectual property protection, but so that we can have the comfort under which to do a full analysis. And the full analysis is our second step. For technologies that we think show potential, GreenCentre will execute a 90-day exclusive option to license from the disclosing institution or the disclosing entity. And it's under this 90-day window that we do a really deep dive on the technology. So we assess things like competitive landscape and the robustness of the technology, the intellectual property position, the potential patent map that can result from this technology. And we start to build in input from our various industry sponsors. And I'll give you a list of who those industry sponsors are. And we have kind of two categories of sponsors. We have industry sponsors that work very, very closely with us. They provide us with access to their organizations and their network of suppliers and customers, expertise and infrastructure to help us initially identify and do a kind of a paper-based evaluation of the technology. But in later stages of commercialization, are active partners in the development and validation of technology platforms. Regardless of what we choose to do after this analysis, whether we choose to execute our rights under the 90-day option or whether we choose to simply return the technology, the results of this analysis are shared with the institution. And this is an important part of the equation because not every technology is going to be a candidate for development. However, we have yet to see a technology which represents poor science. It's all high-quality science, but perhaps science that doesn't have an immediate commercial target. And where that's the case, we tend to share the specifics of that assessment, specifically around the commercial connection between the technology and the marketplace. But not only as a matter of information, but also as a matter of inspiration. To inspire the researcher with some candid marketplace feedback around the sector that may in the future benefit from the next generation or two of advancement in his or her research programs. So it's an important part of the market pull activities that we facilitate is understanding where technologies could have potential if they were to have their focus shifted one way or the other. So for technologies that we believe we can truly help, and when I say we can truly help, I mean there's two things to that. There's two dimensions to that. I mean it's not only technologies that we believe there's a commercial outcome, but ones that we can help get there. I mean, as you can imagine, there are many different ancillary sectors which we just don't have the expertise to advance. And in those instances, we're not going to hold up the development of technology. We'd rather identify other partners who would have a better fit of competencies to advance that technology. But for ones that we're confident we can develop, we license that technology. So we work under an exclusive license from the institution. And under that exclusive license, we cover all of the development costs and all of the intellectual property costs. And again, I can't underemphasize, or I can't overemphasize rather, the IP costs. I mean, intellectual property, unfortunately, is often viewed as this necessary evil, this almost ancillary thing that needs to be done to satisfy some downstream future diligence activities. However, it's core. It's core to commercialization, and if you do not have a robust patent estate around the technology which can ensure an element of exclusivity and at the same time attract investments, it's going to be very difficult to advance the technology. The costs associated with doing so are significant and typically range, on the low end from $50,000, on the high end to $250,000. So it's a significant investment that must be made if you hope to attract the necessary levels of investment to advance technology. And I'll give you an example, one of our case studies at the end of this presentation, where it was not only the technology but also the robust intellectual property position we had, which was able to form the basis of a new company, and we are now days away from closing on our first round of financing into that new company. So under this license, of course, our goal is to have a successful commercial outcome, and when we're successful, we share a large portion of the net licensing proceeds to the institution and to the inventors. The goal here is for there to be wealth generation and sharing of that wealth, not just with GreenCentre, who's done this development work, but with the institution that invented the technology in the first place, in the hopes that that return on investments will catalyze and support future innovations that hopefully we'll have an opportunity to work on as well. And when we get into the real meat of our activities under this license, I mean, it's development, development, and we do the development until such a time as we're able to facilitate a commercial transaction, or until such a time as we run into a barrier that we cannot overcome, whether it's because it's technically infeasible or whether there is a marketplace reality that presents itself that we can't navigate, or whether we simply cannot bring to bear the necessary levels of investments to get the technology advanced. But in the meantime, until we get to that point, process optimization, field tests, proof of utility, scale-up development is an important part of the process, as you can imagine. Especially, the nice example is polymer technology. So where a new polymer is created, typically on the milligram scale, if you're lucky, a couple of grams. If this new material shows any promise, future end users would want to get a sample for their own internal validation and development, and they're typically going to request in the front end 1 to 2 kilograms of material, which may not seem like a lot, but to the academic researcher, 1 or 2 kilograms may as well be 1 or 2 metric tons. It's a huge scale that the academic research community is not used to working at. So this is something that we facilitate as well. Application development, and where necessary, pre-commercial sales to continue to develop the technology. That's what we do, and again, the goal is to get the technology to a point where a commercial transaction is possible. And these fall into 2 categories. For technologies that can benefit from existing infrastructure in a given manufacturing value chain, our preferred path is to license that technology to an organization or to a group of organizations that they can immediately plug into their own operations. For technologies that are truly disruptive and truly platform, these are ones where infrastructure does not currently exist, or that would require a replacement of already existing infrastructure. And in those cases, the path that we typically choose is a new venture path, where we use the for-profit new venture as a vehicle to raise the necessary financing to facilitate the later stages of commercialization. So, important part of what we do is with our sponsors. I mean, we do not do this alone. I mean, we have a clever group of 27 people now, but we couldn't possibly represent all of the skills, and we couldn't possibly buy all of the equipment needed to advance a broad spectrum of chemistry technologies. So we offset that gap by working very closely with these industry sponsors. And these are organizations that support the organization financially, but more importantly, supported through the in-kind contribution of expertise and infrastructure. And in some cases, specific equipment brought into our facilities. And as you can see from this list of sponsors, I mean, it's a pretty impressive list of some very large organizations, and in some cases, some smaller, nimble organizations that each represent specific points along the chemical materials continuum. So it allows us to scrutinize and develop technologies not just with one slice of that continuum in focus, but with the whole value chain in focus. And I'll tell you, the ability to benefit from supplier customer relationships in the course of development of technology is catalytic, and it's something that's often missing in most technology commercialization initiatives. So in addition to this, I mean, we've developed a pretty impressive list, I mean, which is no longer restricted to Canada. I mean, there are some examples of some U.S. universities here. As a source, a pipeline of innovation. I mean, these are institutions that have entrusted us with their green chemistry innovations. And when I say green chemistry innovations, I'd like to broaden that to chemistry innovations, because one of our other lessons learned is that there is a wealth of green chemistry innovation that is not labeled green up front. It's simply labeled as chemical or material science innovation. But when you really probe that technology and you really start to define its potential, you quickly realize that this is a technology that, if successfully deployed in the marketplace, can represent significant sustainability advantages. So it's amazing how many people are working on green and are blissfully unaware that they're working on green. But that's something we're trying to change, as you'll see later about as I speak to the early stages of our green chemistry awareness campaign. Throughout the 5 years, we've developed some pretty strong relationships with chemical, materials, and consumer good companies across the spectrum. This is a sampling of those companies, and I put it up there just to show you the breadth of our network and really how powerful this can become when you look at a technology in its early stages of development, and are very quickly, we can very quickly properly position that technology by drawing on the marketplace intelligence that lies behind each of these corporations. Incredibly powerful, and this is the essence of market pull. So while all of our activities, like any good technology entrepreneurs, we initiate them as technology push activities, by striking and establishing lines of communication with one or a group of these companies, we can very quickly turn that on its head and turn it into a market pull activity. And that is far more powerful in terms of expediting the development and deployment of the technology into the market. And I mentioned earlier that we are working more and more with the future of sustainability. And these are new ventures that are, typically these are 1 to 2 person entrepreneurial vehicles who have a really exciting platform technology that they are developed. Some of them are very, very early stage. Others have been able to bootstrap the development of their platform to a pretty impressive level, but all of which could benefit from the types of skills, investment, and access to market that our organization can provide them. So more and more, we're working with this group of, this group of innovators. So we've been in business for about 5 years, actually not quite 5 years, and in that time, we've taken this paper-based exercise and we've assembled it into to a globally recognized organization with a world-class team that has become known in its ability to not only identify promising green chemistry innovations, but to take a really effective hands-on approach to getting them developed and getting them deployed onto the marketplace. In that time, we've successfully brought 6 technologies from the test tube stage to 6 out licenses to companies around the world, and we've created 3 companies. I'll tell you a bit about one of them in a bit, and already 80 direct jobs in Canada. And that, of course, we hope that'll expand internationally. And important to the government funders out there is that we've leveraged every single dollar of public capital with private capital. So the process works. It's a way to catalyze investment from the private sector, something that is critical in any type of commercialization, not just chemistry, and that you need private sector involvement. And we've been able to do that in a sector which has historically been risk-averse and capital-intensive. And one of the things we're starting to see is a rekindled interest from the investment community in this whole clean tech space. So, green chemistry, I mean, if chemistry makes everything we do possible, then it certainly makes clean tech possible, and that's the case. And it's a lot of the clean tech deals that didn't really quite make it were, you can point the finger to a weak chemical platform. And our ability to bolster these clean tech plays with strong green chemistry technologies is enhancing the likelihood of these entities becoming successful, and they're further catalyzing downstream investment from the investment community. So I want to speak a little bit about communications and marketing, because this is an important part of the equation, because everything I've said today to this moment resonates with a very small subset of the stakeholder group out there. So it resonates with business leaders in the chemical space, and with technical professionals, and with researchers. But they represent a very, very small percentage of our stakeholder group, and we like to think of our stakeholder group as the general public. The general public, who really doesn't understand chemistry, they just, when you tell them chemistry, they just think of these ghastly plants with all of these towers, and solvent recovery towers and distillation towers, and how it's actually connected to their daily lives it's not well understood. And we believe that in order to properly nurture this sector and to see a rapid development and implementation of green chemistry technologies, that the public has to be behind this, and they have to support and demand innovation in this sector. So we've initiated a communications and marketing campaign to that end, where we can hopefully, through the development of educational material and workshops and marketing collateral, all stakeholders can collaborate and together advance discovery to commercial outcomes. So our communication strategy seeks to improve the public understanding and perception of not only green chemistry, but chemistry in general, and then what green chemistry means in this sector. And ultimately, we want to improve resource allocation and policy frameworks to advance green chemistry. We want to advance change or catalyze change through education, not eradication. And so a healthy communications and marketing strategy is important. So with that, we've recently launched, or actually, sorry, you guys are getting a sneak peek. We're about to formally launch a communication initiative, which we call Hug a Chemist. And it's our green chemistry awareness campaign. And I won't go into too much detail now, because there will be a formal communication which I'll share with the organizers at GC3. And everyone will have an opportunity to review material and find out how you can get involved. But it really looks at chemistry and innovation in chemistry as a powerful, it's an enabling force, as a source of solution, not a source of problem. And our little tagline is, if you want to save our planet, hug a chemist, not a tree. And most chemists will appreciate this, but this is a bit of a change for most people that aren't truly familiar with the chemical sector. But at the end of the day, the message here is that it's innovation in the chemical sector that is going to solve the world's most profound sustainability, human health, and economic challenges. And so the more chemists we hug, the more we embrace this sector, the more likely and the more quickly we're going to be able to develop these solutions. I'd like to spend a little bit of time, I'm mindful of the time, but I think I have just enough time to go over one of our exciting case studies. This is the second company we've created, which we've been working on for about 12 months now. And it was a company that we created off a platform which we label switchable water. And it's a nice example of how things come to us in a very early stage of development, a very clever innovation, very early stage, and it outlines the kinds of activities we undertook to get it to a platform technology, ultimately create a company, and in the coming days, seeing closing on a significant round of financing into that company. So the switchable water technology is an invention of Professor Philip Jessup, one of certainly Canada's most well-known green chemists, one of the world's better-known green chemists. And it's an additive system which allows us to control the ionic strength of a salt solution. So we can make a salt solution have very high ionic strength, which is what you would expect in, for example, a table salt, a water solution of table salt. But in the absence of CO2, we can make it behave like a very low ionic strength. And we can flip between these two states simply by introducing or removing CO2 into and out of the system. Very low energy, very rapid conversion between these two states, low ionic strength and high ionic strength. And the chemistry is elegant and simple. It's simple chemistry with readily available starting materials that do not present any toxicity challenges, are not cost sensitive. Simple, straightforward chemistry that we're able to use and harness to facilitate this change in ionic strength. So as an organization, when we saw this, our first reaction was, wow, that's pretty cool. But being pretty cool is not enough. What can we do with this? I mean, answering that all-important who cares question. And it turns out for this particular transformation, there's a lot of sectors that should care. Desalination through osmosis is something that can benefit from a swing in ionic strength. The separation of water-soluble organics, moving away from polyacrylamide clarifying materials for water purification, moving into reversible or switchable clarifying agents that can achieve the same goal without any of the toxicity concerns. Biphasic catalytic recovery, low foaming surfactants, the list goes on and on and on. So we were overwhelmed by the list of potential applications, but we decided to focus on that first one, desalination. And on the heels of that, we did some more development and we validated the suitability of this platform in potable water generation through forward osmosis. And a hugely important sector. I mean, when you talk about some potential to drive the economy, to improve human health, to reduce political strife, I mean, it's all linked to a lack of fresh water. And in Canada, it's difficult for people to understand that there's a big challenge with fresh water because we happen to sit on 70% of the world's fresh water. But many other parts of the world, including the U.S., don't have those same bragging rights. Potable water is a key concern going forward, and we believe that this will quickly overshadow oil and gas in its ability to drive economies. Before people even realize that desalination is really a necessary industrial sector, it's already grown to a $13 billion industry, and it's projected by 2020 to reach over $90 billion. It's a rapidly developing industry, which is in response to our ever increasing shortage of potable water around the world. And the technology that's used to date is one that is not sustainable. It works, but it's not sustainable. It's a process known as reverse osmosis, where I'm trying to simplify it here, but it's basically where you squeeze salt water through a selective membrane and in order to push fresh water across that membrane and leave all the salt behind. The problem with this technique that it requires extremely high pressures. This is something which goes against nature, moving from an area of high concentration to low concentration, and consequently requires a lot of energy. And as you can imagine, if the water is not optically clear, you're going to get a lot of fouling as you push contaminants through this high pressure process through a membrane. So the other approach is forward osmosis. Now this is something that goes with nature, right? So forward osmosis, water flows from areas of low concentration to areas of high concentration. So to facilitate the water flow, you don't need pressure, but you simply need to have higher concentration on the right-hand side of that membrane. And in doing so, water will naturally flow across that membrane from the area of low concentration to the area of high concentration. But when you look at the net result, you basically just created two pots of salty water. So neither of these pots are potable. So while it's intriguing, forward osmosis in itself doesn't provide the solution. And this is where the switchable water technology that I described earlier has the potential to provide a sustainable solution to this challenge. And in this case, what we're doing is we are generating a concentrated switchable salt solution on the right-hand side of the membrane. And because it's more concentrated, we are able to facilitate that same natural flux of fresh water from the salt water, so call it seawater, which is at about 3% salt, into the highly concentrated switchable additive, which we prepare at about 45% salt. So because of that big concentration gradient, we get this really rapid flux across the membrane. And we're able to generate now our 2 pots of salt water, like I described earlier. The magic here is that we can very easily volatilize this salt. So this salt, under the action of some nitrogen or some air with a little bit of heat, we're able to volatilize the salt out of the system. Importantly, we're able to recover that volatilized salt and use it again in future extractions. So what we're left with is water, which by all of our measurements is potable. Now, whether we have to work with the regulatory bodies for them to give us the label of potable, but our analytical analysis certainly demonstrates that this is potable water. And it's potable water that can be produced at a fraction of the energy and a fraction of the cost and a fraction of the consumables that is typically seen in a reverse osmosis system. In fact, our calculations suggest that we can produce potable water at 10 cents per cubic meter using this technology. So I think there's huge potential here. And this is kind of a snapshot into this technology and what we've done to date. And like I said, we are hopefully days away from closing our first financing round around this technology. But it all started from a clever academic discovery. That eureka, that was the first thing we need to do was assess its fit in the marketplace and triage the different market opportunities that we wanted to go after. Make sure that we have a seminal patent estate which can support the expansion of that patent estate into one which will guarantee investors or acquirers of this technology with a degree of exclusivity and therefore attract that investment so that we can continue to develop this technology to a point where we are today, which our target is to assemble all of the unit operations that we've been able to develop since getting this test tube scale discovery into a continuous desalination unit that we can use for more detailed process modeling and ultimately for CapEx estimations in order to raise the capital necessary to build a municipal pilot unit. That's the goal, and I think it's a wonderful example of how disruptive early-stage technologies with the right ecosystem and nurturing activities can get developed into a platform which then positions them for really profound societal change. And that's the story with Flow and Water, and I'm hoping that this is a story that just continues to get better and better. But of course, in this business, you never know, but I'm quite hopeful with this one. And lastly, I'd just like to leave the audience with just a few words about moving beyond Canada. Since we launched our organization 5 years ago, and as I guess our name got out there, people from outside of Canada started to approach us with requests to look at their technologies to help them with their commercialization initiatives. And quite frankly, this was outside of our initial scope, but it's something that we are now looking at, well, how can we do this? How can we take all of the lessons learned to date and work with entrepreneurs and researchers and other commercialization initiatives around the world to help develop and advance their specific green chemistry portfolios. And so as a first step to that, we created GreenCentre USA. And GreenCentre USA was created last year, and it is a wholly owned subsidiary of GreenCentre Canada, and one that recently received its 501c3 designation. And in that time, we've been working with U.S. researchers and entrepreneurs, and we've been assembling a broad group of stakeholders that will ultimately support the expansion of the GreenCentre model into the U.S. So we're in early days still, but certainly over the last several months, I've been really pleased with the amount of progress that's been made with this initiative. And not to get into the details here, but I would just like to leave the group with an invitation to contact me at your convenience, and I'm happy to tell you more about where we are with GreenCentre USA and what our plans are, and if you're interested, how you can get involved in helping us support the expansion of our organization and our business model into the U.S., because it has to be done. I mean, green chemistry technologies and clean green chemistry technologies launched into the marketplace is something that should not obey political boundaries. It's something that needs to be done globally. So with that, I think I would be remiss not to acknowledge our funders, the organizations that had the vision to support what was, like I said, initially a paper-based exercise, which sure, you could put a lot of promise on paper, but it is paper, so there's a lot of risk. But fortunately for us, the governments of Ontario and the governments of Canada were supported us and helped us launch this organization. Currently, we're members of the Ontario Network of Excellence, and also a member of the Centers of Excellence of Commercialization and Research, which is a federal umbrella. And with that, I will turn it over to the organizers, and happy to answer any questions that may come up.
Thank you, Rui. That was quite good and inspirational. And I was going to ask about your work to reach over the border into the U.S., but you've answered it in part. You've just simply whet our appetite to find out more. So I guess we'll have to contact you individually to find out more about that. But that's a very exciting development for us. So let's see. So I invite folks to type in questions into the Q&A box. And I'd like to just, Rui, thank you again, and take the liberty to get the Q&A process going. There was something that you just touched upon briefly, this notion of technology push versus market pull, and I'm kind of intrigued by that. And, you know, when I think about technology push, I can easily imagine you know, your folks kind of trolling the technology licensing offices in universities and talking to entrepreneurs to find, you know, novel ideas and vetting them for their commercial potential and so forth. But in the market pull area, I'd like to hear a little bit more about how you work from that direction, because there are companies that are quite active in the GC3 that we talk to all the time about, for example, their needs, if they're in the apparel and footwear sector, for greener alternatives to perfluorinated compounds for water repellency, or better plasticizers for wire and cable, or greener flame retardants for plastic enclosures for computers and so forth. So to what degree are you also out there, you know, looking for these market needs and then, you know, going around and looking for potential solutions to these needs from sort of the market pull direction?
So, I mean, historically, I mean, people tend to separate those two activities. I mean, there are organizations who focus on technology push, and that's typically the tech transfer communities. Their focus is on selling what we have, right? And then, of course, on the flip side of that, there are organizations that are doing their best to try to sort of genericize needs across a sector, right, and trying to communicate those needs to the research community. And I guess we do neither. I mean, we look at it as a relationship, right? It's we try to you know, one way to look at it is how do you start a discussion with a company like BASF? I mean, one way to start that discussion is to you know, approach them with a portfolio of technologies that they may be interested in. But if their response to your initial outreach is, well, geez, no, that stuff really interests us, then you have to take that as an opportunity to get to know a bit about, well, what would interest you, right? What does keep you up at night? And that's not an easy task, because a lot of the marketplace intelligence that we've developed is, dare I say, a little confidential, right? So these are things that keep plan operators, that leaders of business units, it's what keeps them up at night, right? It's what will satisfy shareholder demands to increase value of their shares, right? I mean, things that are very near and dear to the increasing valuation of a business unit or an entity. And the only way to get that kind of candid marketplace intelligence is through relationships. And the only way to really build those relationships is to have stuff to talk about, which is the front end with all this technology push. So it really becomes a question of the chicken or the egg. I mean, which ones comes first? And to be totally honest with you guys, I don't know where we started, whether we started from market pull or technology push. But what I can tell you today is that when we engage with an industrial collaborator or a client, if it's just a follow-up meeting just to nurture a relationship we've had for 5 years, or whether it's that seminal meeting to get to know them, we do it with that double-edged sword of trying to assemble a portfolio of things that we know would be interesting to them, but at the same time using it as a forum to extract out of that industry partner very specific technical challenges that they have that we could either address immediately through an existing innovation or bring a group of researchers to bear on a well-articulated problem statements to develop that solution for them. So I'm not sure how well that answered your question. It's a difficult one to answer, but the only thing I would say is that it has to be relationship, right? And it can't just be from the technical front. It has to be conversations and interactions that are predicated on at least some cursory understanding of the business that you're trying to sell into. So understanding their pressure points, their pain points, the influences of existing regulations or regulations that are coming down the pipeline, and how innovations, whether they exist or not, or whether they need to be invented, can help overcome those near-term challenges. And where's the company's vision? What is their long-term vision? I mean, many companies want to see, you look on their websites, they want to see that by a certain point in time, they want to have 25% of their feedstocks from renewable resources. I mean, we work with, every single company we work with has this goal. But really, what does it mean? Is it feasible, given their business? Or is it perhaps an opportunity for us to educate them on other green chemistry technologies, which won't necessarily switch them to renewable resources, but will significantly conserve how many non-renewable resources they draw on, right? Keeping that healthy relationship and understanding our clients and their broad spectrum of needs is what's been very catalytic for us as an organization.
Thanks. That is a good answer. That's interesting. So the relationship piece is really critical, and the communication piece. Yeah, I'm getting that. That is very helpful. Good. So I have a question here from Rose Perkins from Dow Chemical, and she's asking, what's the cost structure for your services?
So we have a couple of different cost structures. So I mean, we can engage with a client on a very classical fee-for-service model, right? And it's something that we do to satisfy short-term revenue requirements to keep the organization operating and to keep the organization growing, but more importantly, as a basis to establish that technical relationship with the client. So a lot of our multinational clients, our relationship started as you guys seem like you're good at brainstorming and thinking outside the box. Why don't we engage you for a bit to come up with a clever, unique solution for one of our challenges. And then from that, it quickly developed into more of a collaboration where we with the researchers or the research groups are working with the industrial clients to develop an already existing technology or to see to the creation of one of these technologies. So the fee for service is one. The other is we also look at providing some of our commercialization services in exchange for an equity position in the company. So if we were to work with a small company that's got limited capital, and that company, we believe in the company, we believe in the opportunity it's developing, and we want to help get it to market, we can, in some cases, contribute those services on a non-cash basis and take any gains as future proceeds or equity disposal. For technologies that we license from an academic institution, we foot all of the costs for those technologies. So those are kind of the three cost structures we have. So academics, we pay for everything. Entrepreneurs, it's kind of a mishmash of whether we pay or whether it's an offset or whether they pay entirely depending on their capital availability. And with the multinational clients, it's typically on a fee-for-service basis.
Great, thank you. So let me ask you just a question about your scaling services. I have heard recently from a number of companies that this issue of scaling, getting things out of the lab and into a point where trial size quantities can be produced of certain chemicals so they can be tested, or even having some new products created where they can be put into commercial use to see if the product really performs as promised is really a barrier for certain companies to actually adopt some of these technologies. Can you say a little bit more about how your organization helps with these kinds of things?
Sure. So there's, I mean, the first part of that journey is in my mind the most important one, and that is synthetic methodology development. So when we get presented with an invention which is a new composition of matter, oftentimes the synthetic route taken to producing this material has been one that is drawn on the supply chain known as Aldrich Chemicals. So if someone picks up the Aldrich catalog and they just pluck out the starting materials they need, and they develop a synthetic methodology based on those starting materials, and they produce a final product. And while that's important to get to that inventive step, we first look at the feasibility of the synthetic pathway to scale it up. So can you source commercially all of the necessary starting materials, or is there any special abatement technologies or specialized manufacturing equipment that would be required to manufacture a particular material? And if there is, we try to move away from those. So we try to actually, essentially what we're doing is we're greening up the manufacturing of a new chemical by first developing the synthetic methodology. Once we've done that and we're confident that we have a synthetic pathway which can be scaled, and I'm not talking just about available equipment, but that the supply chains are there, that the products exist on the marketplace, or that there's infrastructure which is congruent with the manufacturing of those precursors, and then we set out with the actual physical scale up. And our facilities to date, although we're in the process of changing that, we're sort of limited at the 1 to 2 kilogram scale. That's what we can do in-house. And that 1 to 2 kilogram is certainly enough to start the show and to get companies looking at it. But if we're successful with that, then companies are going to quickly require 100 kilograms of a prototype material. In that instance, we do not, and we don't have any short-term plans to get up to the 100 or metric ton scale of manufacturing, but we do have a group of industry collaborators that we work with, some household names, that we are able to plug into their facilities to actually develop this optimized synthetic methodology that we develop up front and get it to a point where we're able to produce, even a metric ton of prototype material. Now, who pays for that depends on the category of the technology, right? If this is something that we're doing in support of a multinational's, one of their commercialization initiatives, I mean, they typically foot the bill for that, and quite frankly, unless it's a consumer goods manufacturer, they typically have the infrastructure for that once the synthetic methodology is developed. But in the case of an academic technology, which we are developing to the marketplace, these are things that we assume the cost of, but we don't necessarily do in-house.
Got it. So you're able to take that next step with these industry partners. So that's
Absolutely.
Really key. Yeah.
Yeah.
No, that's quite interesting. Can't do it all on your own.
No,
but these relationships are key.
Absolutely. One day we will. I mean, but before we get there, we're going to need to see some of our carried interests actually crystallize. And with those proceeds, we would look at expanding our own manufacturing footprint to be able to service a broader spectrum of that commercialization continuum.
Great. Okay. Well, that's kind of a great note to end on, just getting a little glimpse of where you're headed. What a fantastic program, and selfishly, I'm quite excited that you're starting to cross the border and think of ways to do more work with us folks down here in the U.S. That's very exciting. So we look forward to hearing more about that. So we're at a minute past, and I'd like to just say, Rui, thank you so much for your willingness and the effort that you put into presenting today. It was quite informative. And I encourage folks to get in touch with you directly with additional questions. If you have any trouble finding Rui, getting his contact information, email me. And thank you, Rui, once again. And here you see on the last slide a couple of the upcoming GC3 webinars. Again, incentive. We'll have the American Chemistry Society, Green Chemistry Institute's Pharmaceutical Roundtable presenting, and the Launch Program presenting over time, dates and times to be announced. So we look forward to having you on those calls. All right, Rui, thank you so much, and we wish everyone a great afternoon and a great week. Thanks again for joining.
Thank you.
Bye-bye.